Hello, everyone, and welcome to today's webinar, where we'll talk about synergistic buildings in the era of IoT. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar is presented by Acuity Brands, the parent company of Distech Controls. Before we get started, I would like to cover a few housekeeping items. Please note the control panel that is on your screen. This is where you can submit questions via the question box in that panel. You can send your questions in for the speaker at any time, and we will address them after the presentation. Also, please note the orange arrow on the left side of your control panel. Clicking on that arrow will either expand or collapse the panel, so please be sure it is expanded so you can access the question box. Also, I'd like to add, if at any time you experience a technical difficulty or have any other type of question, please send a message to us in that question section, and we will address it privately with you right away. Now I'd like to introduce your speaker today, Michael Skurla. Michael is Vice President of Solution Architecture for Acuity Brands Lighting. With a BS degree in computer science and a strong background in electrical design and machine-to-machine and IoT communications technologies, Michael has spent more than 23 years in commercial building automation with a heavy emphasis on networked solutions and analytics. Through his career, Michael has had roles that include work in system design, product development, and programming. And he has led the design and development of several network, dimming, power management, and power control products globally. So with that, I'll hand it over to Michael. Hi, Michael.
Hi, Ann. Thanks for having me. We're going to get started, and I hope everyone can see my screen. We're going to begin here. I just want to put a little preface on this, that this is a Prezi presentation, not PowerPoint. So anyone is capable of viewing this online after, and it also stays up to date. The topic that we're going into today is somewhat advanced in that it's an evolving field. And so I keep this relatively up to date as technologies and information change. And you'll see as we go through this, it's a pretty common thing as this is such a fast moving topic. So feel free to use this address here and it will redirect you to always the most current version of this presentation. Let's talk about some of the expectations we're looking to get out of this. This is a little different. This is not necessarily about technology itself, but it's about what's happening within our industry and the shift from traditional systems into a much more advanced IoT framework and what's feeding into that IoT framework. So we're going to hit 5 things throughout this 1 hour, and that's going to be understanding consolidation that's happening within our industries. Many of us work either in the HVAC industry or lighting industry, security, cameras. All of these are silos, and you'll see how all of this is starting to meld together. The energy saving story that we are very used to giving, saying that we're saving so much energy by putting in something that's so efficient, that story is ending. But it's a much different change that's occurring, and it's much more exciting. And there's a lot of reasons and drivers behind this. I'm going to be introducing a bunch of terminology, some from industries, some you may know, but since we are talking about cross-industry pollination, there's going to be terminology from a lot of other industries that I hope I'm able to expose you to today. And our tools have changed. The things that we have access to build buildings is much different than it used to be. And then finally, people. And this involves us. All of the things that we knew and our jobs were about are shifting very, very quickly. And this is a change in what we have to learn, and a change of our industries has to either embrace or other people are going to take parts of our industry. So I'm going to go into that. So let's get started. How we got here, I mentioned on the last slide that we have silos that have existed. I live in a house where it was built in 1946. It has had many, many upgrades over the years, and lots of things have increased efficiency within buildings over those years. You can look at lighting, going from incandescent, where there was one light on the ceiling in every room, to now having downlights and decorative lighting. Insulation was added. I think I've gone through 5 different HVAC systems within my house since it was built, from what I can figure, starting originally with coal and then moving through different fuels as industries progressed. But the one thing about this was that when you look at this, the evolution was a very, very lonely business. typical trades within a building. There's about 23 in a commercial building. These are separate subsystems that we've had that have strived to be as efficient as they possibly can. Each one attempting to save energy and in the end, save money. So each one has been competing, and we've had a long history of innovation in these silos, going back all the way to 2600 BC with fireplaces in around 800 AD. And you can see this is obviously just a small microcosm of all the innovations that have happened. But really a bunch of things started happening around 1981. That, of course, was the personal computer. You start looking at different aspects that have occurred, and a huge compression of different information technologies started coming into existence, with in 2007 being one of the biggest ones, and that was the smartphone, not necessarily the cell phone. And like most industries, we looked at this and said, it's a phone, right? It's just a single phone, it makes calls. But then it started having services, and it started being able to do significantly more than just make phone calls. In fact, it started to become part of our job. And in a way, these smartphones have moved away from their center feature of making calls and becoming more internet devices or connected devices that we're shackled to for good or for worse, but we're using these in much different ways. And it's impacted much more than the idea that we can communicate with a single person, but it's brought us together in different ways and changed society. And a really good example of this is just in 1999, you would never get into a car with a stranger, and you'd never meet anyone from the internet if you knew what the internet was in 1999. By 2001, which is just 2 years later, we're meeting strangers online. Match.com merged with AOL dating, and all of a sudden, strangers are meeting online. By 2009, we're summoning strangers from the internet with the point of getting into their car to go meet other strangers from online for a date. This has completely revolutionized how we function as people. And this is widely accepted over a 20-year span. All of this has changed. And it's really been sparked by the idea of information technologies changing how we operate. So what has this done to buildings? Traditionally, we've had technology and we've had property. And the buildings that we designed and put our silos into were built ahead of time. We use these different silos to bring things into the building, make us comfortable through heat and cooling, give us light, let us communicate. But they were very segregated from the technology that was actually going in by the people that were occupying it. Generally, when these buildings were built, then someone would come in after there was a tenant and wire the building for whatever business was going in there. And that could vastly change the infrastructure. So in a way, we were doing things twice in some respects. But the idea now is that a shift has occurred where the buildings themselves and the technology going into them are the business itself. And what I mean by that is we're no longer always taking buildings and then finding a tenant later. We're actually creating the data that is going into the building is vital for the function of making money. We'll talk about that a little more in a second. So technology brought a lot more. We've got the personal communication technology, and there's three things that really were the drivers in this. The personal communication technology, connectivity. Number two is the evolved building toolbox. And number three, it really allowed us to bring the idea of a synergistic building into play, which includes all of these silos working together. Let's look at personal technology for a minute. Just in the last 10 years, we've had the explosion of personal devices, the personal ownership of devices. I remember very vividly the first job that actually gave me a phone. I thought it was such a treat, but I still had a separate phone that I had for personal use. We're now cross-pollinating between personal devices and work devices very heavily. And we're using both of them and expecting interconnectivity in both of our worlds, both our personal lives and our work lives. Personal data relevance is becoming very, very important, and this is a very interesting topic. The data that we're getting back from things, we want it to relate to our lives and our business. We no longer want to get lots of just information. We want that information to be relevant to us. Business is accepting the inclusion of devices very, very heavily, even external personally owned devices. A lot of companies now have the BYOD policy, bring your own device policy, which then easily cross-pollinates the idea that I have an iPad, but I'm using my iPad also at work and at home. But two of the things that this has impacted is computers are not disappearing. There was a myth for a long time that mobile devices were overtaking computers. They're not. Computers are still being sold. Computers are still used as development tools, and they're still a growing market. But more importantly, all of these devices that we're walking through spaces with are becoming sensors. They are sensors of our personal lives. And of course, there's a lot of information in the news right now about analytics and the value and the danger of analytics. But in the end, the personal devices that we are holding are sensing devices that not only are allowing us to access information, but are giving others information about us. And there's no nefarious plan, well, I guess there could be, in what that means, but it helps us. The idea that our device, we're walking around and Google Maps is helping us, but there's a relationship with our sensing device, which happens to be a GPS device in our phone, is using a service and giving a service information to help us throughout our days. And that's becoming more and more common, and it's also becoming more and more expected for that to occur. So when we talk about network connectivity, there's also some really interesting other factors to this. Fixed networks are now stable, and Ethernet is the winner within this. For a long time, both in building technologies and in the IT infrastructure, there was other competing ways to communicate. For those that have been in IT for a while, particularly back in the 90s, there was something called token ring. And it competed against Ethernet infrastructures by IBM. Within the building space, we know we've gone through many, many transitions of different building technologies for communication. And that still exists to an extent, but we have stabilized in saying, well, Ethernet and using an IT infrastructure is important, and the commonality has become Ethernet. The other thing here is connectivity is becoming ubiquitous. We expect to be connected, and this can be through both wireless carrier, mobile carrier frameworks, and then Wi-Fi. An interesting metric with Wi-Fi, the second most common reason that a hotel, a customer to a hotel would not revisit a hotel is poor internet connectivity. What's even more fascinating about that statistic is the #1 reason would be bed bugs or cleanliness issues, meaning that we are now equating internet connectivity to being almost on par with personal harm in a way that we would not revisit a property. An interesting analogy in that that's how important connectivity for us has become. Businesses themselves, since the buildings that they are occupying, they are now reliant on much more technology than they ever have before. And this is because we've shifted into a service economy. We, of course, still manufacture things, but even in our manufacturing plants, the technology required for them to function almost supersedes the manufacturing line, meaning there are two things that are now a necessity within buildings for them to function, and it's impacted our engineering: power and communications. Without both of these, businesses cannot function. Banks can lose millions in minutes without connectivity and having power. We are now designing buildings with multiple entries of both data and power for redundancy. And then we're also moving into a different architecture overall, which I'll talk about in a minute, moving into much more of a cloud infrastructure. But you look at these business continuity aspects, and you have capacity, reliability, diversity, resilience, and redundancy, all related to communications and power within buildings. And then the concept of decentralized consolidation, which at first sounds like a misnomer, but it actually makes quite a bit of sense. For the longest time, we had companies creating their own data centers and deciding that the safest place to keep their information, particularly if they were a company that required data storage, was internally. So they would build up their own data centers, they'd hire up their own staffs to control these data centers, they would scale hardware on their own. And it was a very, very expensive proposition. This has, however, changed. This has moved much more into a SaaS model where we have the ability, all of these companies are moving all of their information to a cloud infrastructure and then using services based on that storage of information into the cloud. And of course, everyone thought for a while there was a huge risk in this. The idea of a bank storing all of their information into a cloud infrastructure owned by someone else. But then when you started carefully looking at it, you started realizing that, first off, this moved from a very intensive capital expenditure model over to an operational expenditure model, meaning the costs were very controlled as to what they were spending, and it didn't involve a significant amount of human capital. That also introduced a significant amount of risk. Moving to a cloud infrastructure offered a hugely secure environment that companies such as Google, Microsoft Azure, Rackspace, and others had very qualified individuals and infrastructures to support. But there was also other advantages to this. Beyond just security, you had scalability. You had the ability to quickly scale and increase the size of data throughput and services without having to actually physically build larger centers and hire more people. The stability was greater. These companies were capable of much more rapid backup and redundancy programs. And they were very agile. So as global compliance became an issue within the IT industry, these larger companies were able to invest in the expertise to do that instead of smaller companies when globalization was required within their businesses. So this brings us to the IoT portion, and it's interesting because all of these technologies were going along, and then we all of a sudden had an explosion within what I like to say the marketecture of IoT. And we've heard about IoT a lot and the idea of IoE, the Internet of Everything. And there's a lot of misnomers on what it is. People have commonly said, oh, well, it's data and it's all this information. Well, it is in a way, but IoT enabled us to use a common platform, a common way of connecting things using IT systems to bring lots of various dispersed sensing technologies in and then do something productive with it. So the interesting thing is we are storing this up into a cloud infrastructure. So we have the idea of cold data. And we have been generating in the building field cold data for a very long time. What is my temperature? Is a valve open or closed? Are the lights on? What level are they at? All of this is interesting information to store, but not particularly useful. And we've been generating this for a huge amount of time. In fact, building management systems have generated cold data for an incredible amount of time and generated reports. The thing that's really changed, though, is that converting this to hot data is where we've really started to excel. And it's the idea of taking all of this cold data that we've been generating within buildings, within all of these silos, not just one, not just things that were connected historically to a building management system, which would have been HVAC or perhaps refrigeration or maybe lighting. But it's saying, let's connect to all of these different facets, even understanding of elevators and where they are, understanding of occupancy, and let's turn this into actionable hot data, things that matter. And that's through analytics platforms and business intelligence platforms, BI platforms. We're going to do an interesting poll on hot and cold data now that people can have a look at. But the business intelligence is a way to harvest all of this into actionable outcomes for people. And we are very commonly thinking of people as facility managers, but that actually isn't the case. Facility managers are one of the stakeholders that we can create hot data for. But there's lots of other players that are interested in that data. And they're people that you quite often don't think of. In a retail store, the idea of a marketing group for a retail store, they are very interested in what's happening within the store and actually what type of information can be extracted from a building management system and other systems, because if it's analyzed in a different way, it can have tremendous value on the operation of the business. So there's a lot of different facets that are coming together in different subsystems. And one area that has certainly exploded within the building field that came out of this IoT revolution is we've got HVAC, we've got security systems, we've got lighting systems, and now navigation systems are becoming part of the framework that we're looking at within an entire ecosystem. And navigation has a bunch of history behind it. You know, we started off with piles of rocks as human beings for navigating around. And the trend has been quite slow. Around 1757, we got the sextant. That was the biggest change. 1600 BC, we did involve with maps. But GPS came out in around 1993 from the Department of Defense. Now, it wasn't necessarily commercialized until 2000 when something called selective availability was removed. And also the chipset started to exist that phones started to get GPS technology. So we have GPS, and everyone understands what this is, global positioning, but the problem with GPS was it never really did well indoors. So you would be able to get a wonderful map to the grocery store, but the minute you stepped inside of that grocery store, you lost all navigation and you'd never be able to find the Cocoa Krispies. So indoor navigation changed that philosophy. And it's been around using Bluetooth technology for about 10 years through different formats, using something called trilateration and Bluetooth pucks. And these have been experimented with by airports and retailers for years and years and years in the idea that they can get accuracy down to a few meters. So someone walks in with a phone, they happen to have Bluetooth on, and they can navigate around the space. There's other methods that have used it as well. Wi-Fi infrastructure has been quite good at navigating within spaces. It had its own drawbacks. It was relatively slow and didn't have tremendously good accuracy and no sense of walls. Bluetooth was an improvement on this. But these style of systems have vastly increased because retailers and office buildings are looking for better ways to track people. And so this is becoming part of that IoT story and part of the interconnectivity of building systems. An interesting thing within buildings and sensing, we've always known that someone's in the room. We've never known really how many people are in that room. Without very expensive methods such as video analytics or other very cost prohibitive methods of dealing with occupancy. This eliminates that and allows several different applications to harness the idea of geolocation using what people are carrying around with them. And we talked about that earlier. That is mobile technology. They are a sensor, and so it can help them navigate. But on the back end, we can use that information as they're navigating for our own purposes within the building space. One advanced technology beyond this as well is called visible light communication. And that's an area where lighting is now adding to the navigability of spaces as well and getting down to hyper accuracy, down to about 10 centimeters, using light technology in conjunction with Bluetooth for navigation. This is actually getting deployed very heavily into spaces and links into the IoT framework, but it's being used all over the place within retail right now, room availability, health care and correlation of care is a big deal. Knowing a machine, a doctor, and a patient are all within proximity of each other is quite a big deal to insurance companies. But then there's lots of other purposes that this is being used, particularly when you start looking at location awareness in relation to the other silos within the building. So what are other aspects beyond just navigation and beyond just HVAC and all of these other silos and trades? One of the larger things that's happened is that we have taken all of these different frameworks that used to give all of this information, and we're turning it into hot data. And then we also have user interfaces that have become an accepted part of our lives. And Apple actually gave this to us, closely followed by the Android platform. We used to have to log into different systems and understand what's going on in each separate subsystem of a building. That's changed. The idea of a single pane of glass within a building or an ecosystem is becoming very, very common, even in our home lives. Anyone using things like Nest within their homes understands that, great, that's controlling my thermostat, but now it's also can be my security system and my doorbell. And the idea of an ecosystem that we're buying into and going to one app to control my home is becoming very, very important. And within buildings, it's becoming the same thing. The average lifespan, and I shouldn't use the word lifespan, the average employment time of a maintenance and engineer within a building is 5 to 7 years. And if that same employee has to understand 9 different software ecosystems to control and monitor and manage their building, when they leave, what happens to that? Chances are they never understood all 9 of them anyway. They really focused on a few of them, and the other ones they never either had to touch, or they didn't understand, or they fell out of commissioning. The idea of a single pane of glass through an interface and a user experience that someone can rationalize and understand is becoming a very powerful tool within the building space. And then the final thing that's happening within this market is the social aspect of all of this. And it's interesting because all of this data that's coming in, and then these user interfaces are allowing us to not only create dashboarding, which we know has been around for a long, long time, and impact how people use buildings because they can see how much water is being used or how much electricity they're being used. And this is actually a code feature at this point, depending on where you live, but also the idea of retrainment. And this actually came from Nest. But this is being used by several companies these days. The idea that if we can promote contributions within buildings for people and have them understand the information, it will change their perception and their usage patterns. And so Nest has done this very, very well. This is actually mine, where it shows other Nest units in my area, and it gives me leaves. And every month I get leaves, and it balances it between my neighbors. Am I more efficient, less efficient? And then I can adjust how my next month would be temperature-wise to see if I can improve that. And it's interesting because studies have gone into the idea of retrainment even in commercial offices. And if people are engaged with their surroundings, particularly in lighting and temperature, and they understand the impact, they will reduce their footprint, their energy footprint on their own. And you're talking in numbers of 9 to 12%. Lighting control was an interesting one where they studied where if an individual in their workspace could control their lights, generally they would lower them. So it's interesting, the idea that if you can add participation to people, it impacts outcome. So tying this back to the IoT and OT, and I'm curious how many people have actually understand the concept of OT, and I'll explain it in a minute. Let's go back to the myth of what IoT is. I asked last year on the ASHRAE, at the ASHRAE show, what is IoT? And I only asked 20 people. and I got some very interesting responses. 2 said it was a data service, 4 said it was a product, 6 network controls, 8 it was a protocol. Regrettably, all of those were vastly wrong. And number one person said it was stuff working together. And I'm going to give that the heart because it was the closest possible right answer. IoT can be defined as the spectrum of technologies for information processing. It can be hardware, software, and communication technologies and related services. Generally, and this is a very important fact to this, is it does not include embedded technologies that generate data for enterprise use. And the way that I like to explain this is the factory floor. So you have an entire company, and that company produces widgets on a factory floor. The company itself, I'm sure, has email, it has accounting, it has different financial services and marketing, and all of that is on the IT infrastructure. But that widget manufacturing line is actually what's known as operational technology. And it's hardware and software that makes the actual product work and produce. So it stamps out the product, it may squirt code into the product firmware to make it work. And traditionally, these 2 worlds within the same company would live completely separated. The operational technology, which was the core business, would have their own little software that would be running that production line and sensors that would run how many pass through the production line, and it would be a different world on its own. And IT would, of course, be its own little world. And the division was put there for lots of reasons: security reasons, intellectual property reasons. But at this point, those 2 worlds are blending, and it's blending very, very carefully. There is a value in having IT technology and OT technology as one. The idea that we can monitor how many things are passing through the widget production line and use that in a financial system real time, not just recorded output, is valuable. And I'll show you a great example of that in a little bit where this has actually been deployed. Let's dig into what this is, though. The idea of a synergistic building is all of these different silos, both the IT silos and the OT silos, breaking down and communicating together. It's not a new concept, by the way. It's simply a concept that's somewhat been lost. Pre-20th century, the architect was the builder. We dealt with things like site-sensitive land, using local materials, passive solar designs. We thought about where the sun was and all of these things. But this somewhat got lost around 1930. William McDonough, an architect, said it best that most conventional practitioners of modern design and construction find it easier to make buildings as if nature and place didn't exist. In Rangoon or Racine, their work is the same. We can build a building in Florida and we'll build the same style building up in Maine. It doesn't matter. It's a building. We'll adapt to codes, of course, but the area that's around it didn't take a huge precedent into adapting. And that's changing now. But we're trying to foster into this with the idea of synergistic systems. The idea that we really, really want to change the philosophy on synergy is the creation of a whole that is greater than the simple sum of its parts. So we don't want to say that we're taking HVAC and we've got a 10% savings on this silo because we're using this certain style of system, and then another 6% on lighting, and then add it up and say, look at all these savings. We want to see if we can actually harness all of these systems together and not just get the efficiencies out of the silos. So let them do what they're really, really good at, but then pull them all together and say, no, we can even increase this because of the sharing of information. So if you're getting a 10% savings out of lighting and a 10% savings out of HVAC, we want to say, how can we get 25% savings, not 20? And LEED started this philosophy originally, and they did a really good job on some basic synergies between things, saying, hey, if we give bike parking, we can promote bicycling to work, and it would save on carbon emissions, or not smoking in a building lets us have require less airflow within a building, and it's healthier. We're saying we're going to let all of these subsystems work and do what they're really, really good at. But then we're going to connect them all together and share information together to attempt to extract this greater good. And when you look at this average subsystem within a building, we have a lot, and people don't think of this. And some of them don't think of these as actual systems, but they are. You've got electrical, communication systems are growing, and these are just 6 of the most common at the moment. Mechanical systems, of course. You've got movement systems, things like escalators, elevators, ADA access, that are huge energy users. And then you do move into the OT technologies that we talked about before, which were things like inventory and point of sale systems that can communicate back, life safety, the geospatial that we talked about, and the geospatial can have an impact on all of these together. So instead of having all of these, and instead of just looking at the ROI of each one of these separate subsystems, we're attempting to tie all of these together on a common infrastructure using IoT technology and go after building savings. And we're talking about both first cost and reoccurring cost, the well-being of both the occupants and the building itself, and the productivity of the operation that's occurring in the building. And there's some interesting studies that have come out of this when you're actually implementing a system like this, tying these silos together. You do get a material first cost savings of roughly 6 to 9%. Now, this was based on a retail study that was actually from a restaurant. And people say, well, where are you getting this 6 to 9%? It's quite simple, actually. If you think about it, in an average room, you have 3 sensors doing exactly the same thing. And this is just one example. You have a motion sensor telling the lighting system, hey, someone's here. You have another motion sensor in the room telling the HVAC system, someone's here. And then you have another one, perhaps from a security system, saying someone's here. There is absolutely no reason you need 3 sensors in the same space saying, I'm here. That could be limited to 1. And not only does that eliminate the cost of 3 sensors, it eliminates the cost of a wire plant to all 3 of those sensors, and a separate software controlling and commissioning all 3 of those sensors. And so that's where that 6 to 9% comes from. It also obviously eliminates that installation labor, or lowers that as well, 6 to 12%. And this was from the simple fact that you're not pulling 3 wire plants. You're not having someone physically install those sensors and program those sensors. You need 1. And I'm giving the sensor example as just it's a very easy low-hanging fruit. But you can look at this and say there's a significant amount of redundancy in devices that we're acquiring sensing technology from. Beyond that, we're allowed to with all of these separate systems connected together, we're able to get involved in monitoring-based commissioning that allows us to look at what's going on a regular basis and make adjustments as time goes on. This fosters ongoing commissioning and also allows us to do something called predictive task tuning, where depending on the analytics you're using and things you're looking for, we can modify and make changes to buildings over time to adapt for changes. Something that's not exceptionally common when you're just getting a spit out of lots of cold data. So one misnomer is people have always said, well, a traditional BMS system, isn't it synergistic by nature? And the answer really is no. Traditional BMS systems have attempted to water down solutions into the lowest common denominator. So an old school BMS system that was just doing building management grew out of the HVAC industry. It handled HVAC exceptionally well, but then when you got to lighting, it would handle lighting okay. It could turn lights on and off, but it wouldn't necessarily do everything a lighting control system would do. Same with security. It wasn't a full security system or an access control system, but it could look at it, give off triggers, get some information back, but it was never designed as a security system. The idea of a synergistic system changes that. The idea of a synergistic system says, well, let's let all of these other subsystems thrive. Let's let the lighting system do what it's really good at, and the HVAC system do what it's good at. The access control system, let it do what it's exceptionally good at. But let's have it all communicate together and think ahead of time on how a newer style building management system that's IoT enabled can look at all these and make intelligent decisions. That is the true difference. So you look at this and you say the practical reality really is we used to have a building management system sort of in the middle, and it would do some other stuff, but now we're looking at peripheral bubbles. We're doing things that are melding over into other competencies and sharing data between these to achieve a higher goal. There's 5 technological architecture steps to this new style system, and it is a different way of approaching things, really from a pragmatic approach. You're looking at this differently, and we're not saying it's vastly different technology, but it's the approach and the design philosophy that has changed. And we start off with the idea of data, and that is, you can see on this slide across, very cold. This is coming from sensory networks. And a sensory network is anything that is out there that's taking data. It's cold data. It could be a thermostat. It could be a lighting controller. It could be an access control device. But it's generating data. We're then going and connecting to that data and pushing it up into a data storage platform. We're not doing anything with it yet. So we've gone from data to connecting to storage. We're then moving into the analyzation phase. And in that storage platform that could be cloud-based or local-based, you're then looking at all this data and contextually interpreting it into actionable outcomes for individuals. And we can look at this much more graphically and say, all right, how does this work in practice? On the left, you have all of these data sources. And notice some of these data sources are not just building systems. We can relate to other things. We can say we're going to be looking at our HVAC and our water and navigation and point of sale systems even. And then we're also getting data and we're reaching out into Google Weather or Google Traffic. And we're bridging all of this together, connecting it and then storing it. And then in the analyzation phase, there's not one analytics package. And this is really where things are changing. What that top cog very well could be our building manager. And it's generating data based on all of steps 1, 2, and 3, letting him or her know, hey, something's wrong on the roof with this, or something's wrong in room 532. But a different analytics engine below, harnessing the same data, could be giving marketing information, access information to another set of people based on the same data. And you can look at this in a very interesting way. And so this slide is a fake concept of a water park. And I made this up a while ago just to say that this doesn't even have to be a commercial building, but it's a place where we have water. It's a place where we have heating and air conditioning that are in buildings, a campus setting. You've got lots of people and lots of employees. And you can see that from an outcome perspective, we could theoretically have, in this example, 6 different analytics engines giving 6 different interpreted outcomes to different people from the same data. So you have Jim, who's the facility manager, and he wants to know important stuff. He wants to know, are the lights on? What's the temperature of the restaurant? How much, why are the water rides using more water today? But then right below it, coming from the same sources of data, is Susan, the marketing person. And they would like to know how many people came last week and walked past the ice cream shop. When it's warmer, do people eat inside more? This can be done with occupancy data and also knowing how many people have passed through the front gate and how many people have walked through even with a cell phone. Bob the accountant has a different set of things that could be interpreted in different ways. The lifeguard, and then visitors even built into their marketing and app. How busy is it today? How is their parking? What is the best way to get to the park today? So all of these things are coming from the same building information that we generally have thought of in the past as just saying, is something broke? The data can be much more useful and packaged in much different ways. So the synergistic system, though, there is a huge array of new technology coming into existence. I give this slide, not that I'm going to go through everything here, but there are some massive things that are currently in the works and changing. In the upper right, the storage, and we say death of the enterprise. The idea of enterprise storing on site is really in the decline, whereas cloud platforms are really growing. And this is happening all through the building management space and IoT platform space, saying that, no, we're going to really push this data out so we can have third parties analyze it or store large arrays of information. The connectivity layer is changing. We're all very familiar with BACnet and also proprietary protocols that are out there. There are a lot new sensing technologies that are coming into existence, and really keep an eye out for things like 6LoWPAN, MQTT, and DSA growing. Also wireless changing and things like LoRa. We're really after outcomes here, but one of the biggest things that's driving those outcomes is the analyzation layer. We are seeing that building management companies are exceptional at the building analytics, but we're seeing, because we have all of this data within these buildings, we have the capability of doing so much more with it. And so there are whole companies at this point generating these things called microservice-based analytics. And they're very vertically specialized. So there are analytics engines just based in, say, clothing retail that can use information for very unique ways based on the information that we're taking in through our sensory networks within buildings. So to really wrap this up, is this real? Yes. This is out there now, and it's actually getting deployed on a regular basis. A lot of the last 24 months have brought this to us in both IoT platforms as well as newer style building management platforms that are enabled by IoT. A lot of people say, well, where do you invest in this? How is this changing everything? This is interesting from a friend of mine, and I found it on LinkedIn. And this was more on the lighting industry, but it said the lighting industry needs engineers with diverse backgrounds. This applies to anyone within HVAC and security as well. The industries, as we can say, we've eliminated 3 sensors with 1 in a room. But the person designing that has to have enough knowledge and understanding then of not just their own trade that they may have grown up in. They also need to understand the other trades or work with partners that understand a large array of their other fields to make this financially possible. And this has really evolved project teams in larger buildings. A whole new industry and a whole new field that's come into existence is master system integrators. And these are not system integrators that we traditionally have worked with within the HVAC space. These have generally come out of the IT industry, where they're building up infrastructures for data to flow using Ethernet backbones. And allowing access to others to come in. And buildings, remember we talked about in the beginning, property and technology are merging. This person is being involved before the building is even built to prepare the building for all of these subsystems to tie together in a synergistic way and allow that ecosystem to exist. There's some interesting case studies that actually have succeeded on this, and one of them is CBRE. They created their own platform based on this philosophy. And as some of you may or may not know, CBRE is one of the largest property management companies in the world. They have buildings that they don't build generally from the ground up. They manage buildings that have lots of different building management systems and lots of silos. In fact, each building is very, very unique. And they wanted a way to be able to tie all of this back together per building and then look at it centrally and be able to actually save their tenants money in energy costs. And they used an IoT ecosystem to do this, to tie all of these different parts together, all of these dispersed legacy building management systems and then other sensing devices that just happen to be there, and harness this. And it's interesting, once they did this in a way where they were able to look at the data, create their own triggers, so they could say, hey, if a door's open in the back, we're not going to allow the air conditioning to run when it's 100 degrees outside because something is wrong, instead of just running it consistently. They were able to get an ROI on this for 3 to 5 months and pass these savings on to their occupants. And so this exists and it works. And there's a very interesting study, as you can see on the slide, that you can go down to and look at it. But there's other case studies like this out there. Microsoft has done some of these as well. So the moral of the story here, it really is, you need to learn beyond your trade. You need to expand out beyond just what you know now. Smart lighting, smart HVAC, smart, we hear it all the time. In the end, all of these are trade silos. And we're looking to really bring these together and tie them into one. The purpose of the data is the future. What you're doing and converting that into hot data so you can take actionable outcomes is where we're really heading with this. And we're really designing toward those outcomes. We're not just designing systems. Systems are great, but a system that's just a system for no outcome purpose, no definable purpose, doesn't do much for an individual. There's a huge amount of reference information on this. You can find this all in here. A number of contributors to this as well. As I said in a wrap up, Distech sponsored this, and I thank them for that. They have a very interesting building management solution that is IoT enabled, and I think it's a fascinating way, because in the end you have to have an infrastructure to build this into the buildings. You can find their information here, and the Eclipse controller is fascinating because it really enables this very quickly within existing buildings. And I will take any questions at this point. I think I'm exactly on time. I do want to say that this presentation, again, will be available and you can review it. It is an IES presentation in the end that I do keep regularly updated. So Anne, I will turn it back over to you.
Okay, thank you, Michael. Thanks for that really wide-reaching presentation. A lot of good information in there. Appreciate it. So yes, and thank you to our attendees for sending in questions. We do have time for a few, so I will put out kind of the broadest question that I think might help recap some of what you've talked about toward the end, especially regarding synergistic buildings. So what do you see as the biggest hurdle for the facility side of things, and maybe for the other stakeholders, but facilities, since it is our main audience today, what do you see as the biggest hurdle from a technology perspective regarding a synergistic building solution, for instance? I see you had put 5 technology architectures in your slides, and that was data, connect, store, analyze, and action. So maybe based on that, what do you see as the biggest hurdle in your work from the for people who are listening in today?
Great question. I think one of the biggest ones is bridging the gap between the building management field and the BMS field and the IT world. These two are well, it was interesting because about 6 or 7 years ago, when you tried using IT infrastructure for anything within the BMS space, it was there was a friction that occurred, and for good reason. Security was not sort of the top of the boat within the BMS world, and so mixing it with things that could have business data on it were problematic. Now that with newer style BMS and IoT solutions has been resolved, and I think some of the mistrust between the two has been resolved. But the problem you have is that the IoT or the IT organizations do not have enough understanding of building management to really know how to deploy this and manage it well over time. And on the flip side, the building management folk, I believe this is changing probably more rapidly, need to understand more about the IT infrastructure and what's going into the building. I think that is actually occurring much quicker because we're seeing within the consolidation of our fields quite a few IT-related businesses cropping up, and IoT has helped this. So you have system integration firms and design firms that are now also handling infrastructure wiring and IT deployments within buildings. But when it comes to long-term maintenance of the building and long-term maintaining these synergistic systems, who's in charge? It can be a finger pointing that I don't think has been resolved yet. The thing is, technologically, we have all the stuff, but who sells it, who deploys it, and who manages it long term, I think still is a work in progress.
Thank you. And just to piggyback on that, we did have a question that just came in. What solutions or what strategy do you suggest for starting from scratch? You know, for a building that doesn't have much of this technology in place, or much of the base in place, I guess I should say.
So the first thing, if the building really has nothing in it at the moment, and I don't mean nothing, it probably has, you know, a standard HVAC system, a standard probably not even a lighting system, just switches on the wall, maybe no security system. Getting involved at the ground level of a more modern day BMS system, I think, is the way to go. I talk about the Eclipse controller a lot because I'm fond of it, not just because I work for Acuity, but because it's a network native device. It was based on the idea of an IoT device first, with heavy building management capabilities, and it also was not proprietary. It doesn't involve a huge amount of proprietary technology that you're vendor locked. That's one of the things that's been very scary in the BMS space, has been sort of you buy into something and you're stuck with it. And that's, I think, one thing that Distech has done quite good. But getting involved in a building management system and sort of integrating it slowly over time, I think is probably the best way to get involved. But it's easier to do, obviously, in a new construction building. On a renovation, you sort of want to pick and choose what trades you're going to start going after. Remember, a synergistic system, the whole theory behind it is that it's more than one trade that you're controlling. So your barrier to entry is really to say, where are the two facets that I want to get started in, and then being able to grow from there. I hope that answers it.
Okay, thank you, Michael. And I do want to let everyone who's on the call know that if your questions are not addressed online, we will go over a few extra minutes, but I just want to let you know if your questions aren't addressed here, we will share them with Michael and he'll be able to address them with you directly. So those will be addressed. So yes, Michael, we do have time for a few more. So I'm going to jump into something that's a little more specific. And it's asking, where do you think video surveillance and analytics plays a role? Do you see it as a critical application, not only for security, but also for business intelligence?
That's fascinating. Yeah, video analytics had a real renaissance a few years ago. You had companies really rapidly get into it. And it came down to one of the things that I mentioned was we've always been able to tell someone's in a room, but not be able to say how many people are in a room. And it's not just about people, it's about cars, it's about all different ways of being able to pinpoint exacts within a space. Video analytics has remained expensive to date, so it's I don't want to call it niche, but it is still niche. It really has a defined purposes, but it's growing. The interesting thing about that is I think some of the other technologies will supplant its use indoors. A great example of that is people were looking at video analytics to do space utilization for quite a long time indoors. But you start looking, do you really need that accuracy? When we know for a fact that 94% of people carry a cell phone with them. And if we can tell if how many cell phones are in a space, is that margin of error good enough to be able to count what's in a space? And I think it is, but even more than just people inside, there's other methods of tracking things. And so we have near field communication technologies for things like inventory that are really getting down to the price point where you could stick something on every single box in your warehouse and not have to try dealing with things like video analytics to see how many widgets are in a space and such. Saying that, it has a great purpose and it does very, very well. I've seen exceptional applications outdoors. And I think there's going to be a place for video analytics, particularly with edge analytics and where you're doing video processing not back at a central location, but out in the field in outdoor applications quite heavily. Parking, traffic management, even crime detection and crowd understanding. There's some really neat applications externally in the outdoor environment that I think will take hold. So I can't say that's answered your question, but I do feel it's a mixed bag for analytics. Interior, it will continue, I think, to evolve to other technologies. Exterior, I see nothing better out there.
Thank you. So another comment and question about the master system integrator role you had mentioned in terms of the project teams and building teams expanding and changing, with this technology that we're going through. So master system integrator, great concept, one attendee wrote. So his question from there was, what is the solution that's typically used looking at a master system integrator input? Is there a certain brand, or is every building different, maybe requiring specialized applications? Like, I guess, what are you looking for in that integrator? Sorry.
Yeah, so a master system integrator isn't necessarily a technology. It is a person that is cross platform knowledgeable on the network requirements of all of the systems that are proposed for the building together. And an interesting slide that I have on that is, sorry, one example of one of those companies that's doing it, and it's just a consultant, is called Fix Consulting, and they're operating as one, but there's others as well. That slide was actually from them, and that's why they're in here. It really is the idea that you're not, the master system integrator to me is an engineer, and that's how a lot of people are treating it, an engineer or a consultant that then is reaching out and sort of keeping an eye on all of the technologies that are out there and saying, okay, how is this all going to mix together now, but also keeping an eye on the future and ideally what the tenant is within the space. If they know that someone's moving in there for the next 12 years that has a certain specific technology needs, how does that mix with the rest of the building technologies, or how would it be perceived? In a way, sometimes they're having to hedge. They're having to take guesses on the future, but they're educated guesses on that infrastructure. So that's, it isn't a technology though.
Thank you. So, okay, we'll do just a few more since we do have a number of them coming in. Let's see. We have Internet of Things will require more hardware installed everywhere and on everything to make it more useful and actionable. How does that offset the savings mentioned? I guess that's sort of a return on investment question.
It is, and you're right. There's a couple of advantages and disadvantages to it. So, yeah, the Internet of Things does require what usually people call edge devices. And edge devices are, for all essential purposes, a bridge or a gateway that's taking in all of the interior data and stuffing it out to a cloud destination. In general, those edge devices are relatively inexpensive. much cheaper than traditional building management solutions have been. So when you start looking at the costs we used to spend on legacy BMS style systems, particularly when you're saying, oh, okay, I need a lighting system, I need an HVAC, or I need a lighting control system, an HVAC control system, security control system, perhaps CCTV control system, and then I need a way of pulling this all together. The costs have not been higher. It does come down to the original design. Now, I will say if you have to renovating or retrofitting buildings, depending on how proprietary they currently are and what systems they currently are, it can be a mixed bag in cost. So there is going to be a cost. I think much of it will be offset by the redundancy of the parts within the systems and also how intelligent the design is. I don't have a good answer on that one. When we've done cost estimates though on it, we have come in at or below, at least the projects that I've been working on, but I've also seen some designed very poorly that absolutely you're just throwing more hardware on top of hardware and you start to question, what am I really getting out of this? I do want to add one thing to that though. You have to look at all of this from a bigger picture as well. If you're looking at true just hardware and installation costs, that's one way to look at it. But if you look at the long-term, how many people does it take to maintain this? How many different extended warranties am I going to have on this? What are my goals within the business to allow my employees to have access to this, and even in some cases software development costs or SI development costs? You have to take all of that into a factor. So there's a bigger financial picture that you have to look at.
Okay, great. Thank you for that. Then we have time for, we'll do one last question. And again, as I said, thank you to everyone for the questions that have come in for Michael, and those will be addressed by Michael offline. But Michael, I do want to ask you this last question from one of our attendees, and it is, where can we learn more about Internet of Things technology, overall, so that when I bring in a vendor who's trying to bring everything together, I will actually understand, what they're talking about, what they're trying to explain, and how it, and to ascertain how it will impact that facility. So, are there any resources you can share aside from yourself, of course, because you've done a great job today?
Yeah, I should go to the last slide. Of course, you can contact Distech on it. Also, the Acuity Brands website has a number of different white papers and topics on it. There is both ASHRAE and IES have done an incredible job of constantly pushing information that's coming up on this, both in educational seminars and on magazine articles. So anyone who gets the ASHRAE magazine, LDNA is the IES one, and actually they're doing a whole issue in June on IoT again. They did one last year, and it's fascinating because those two we talk about companies mixing their technologies, but those two trade organizations are naturally talking significantly about each other. And so you'll find a lot of information in June. I actually have an article. The feature story is one that I wrote going in June into LDNA. So the trade organizations have been a huge success, and there's a lot of classes now coming out on this within those trade organizations. I'm a huge fan of both ASHRAE and IES on this, because I feel they have been the most proactive and also marketing agnostic on how it's impacting our business. So I'd keep an eye out on those. And hey, I'm going to plug myself. Pick up the magazine in June. It's a great article.
Okay, well, thank you. Thanks very much, Michael. I appreciate you answering those questions. And as I said, we'll share those additionals with you. So thank you again, Michael.
Thank you.
And thank you to Acuity Brands and Distech Controls for sponsoring this event today. And of course, our audience for attending and for sending in all your questions. I'd like to let you know that a recording of this webinar will be available online at facilityexecutive.com, and you will also receive that link to Michael's presentation. So thank you very much, everyone. Have a great afternoon.